As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-thru or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com. With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil Degrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay, to communicating with your boss, to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk Cosmic Queries. This is the Venus edition. Is there life or is there not? And my co-host for this is longtime friend and funny as all get out, Paul Mecurio. Paul, welcome back. Welcome back to Star Talk.
Thank you. Yeah, it's been a while. It's great. Always fun.
I was on your podcast.
Yes. Yeah.
And the name of your podcast was the Paul Mecurio Show. Is that like the best name you could come up with?
Well, we workshopped it for 6 months. And it's like we focus grouped it. Yeah,
focus
exactly.
group.
Yeah, it's on iTunes, and we got I guess have an array of interests in people. So it's everybody from you to Paul McCartney, Kevin Costner, and
excuse me, name drop. Excuse me.
Yeah, I got to get people to go listen to it. I got to drop your name.
No, it's great. So it's great to have you on. And so I've read about Venus, but I'm not an expert on it. And so I had to call one of my old-time friends and colleagues, David Grinspoon, Dr. Funky Spoon. David, welcome back to Star Talk.
Thanks, Neil. It's great to see you, and always fun to do Star Talk.
Is your Twitter handle still Dr. Funky Spoon?
Oh yeah. I am Dr. Funky Spoon on Twitter.
Okay, and you're also a part-time musician, I guess. This is you riffed some lines about, was it the Big Bang or planets on an earlier episode of Star Trek?
Well, we did the astrobiology blues.
Astrobiology blues, looking for life blues. Yeah, that was fun. Thanks.
Yeah, especially these days when we're all kind of stuck at home. I've been playing a little bit.
Mm-hmm. Right, excellent. I see a guitar in your back there. And where are you now in this moment?
In Washington, D.C., in an undisclosed location in a basement.
Oh, so in your parents' basement. Okay. Paul, let the record show he hasn't moved out yet. He still hasn't launched.
Mom, meatloaf!
I'm trying.
It's like that scene with the Will Ferrell. Mom, meatloaf! And he just screams for meatloaf.
Yeah.
Anyway.
Yeah.
Hey, you're making me hungry.
So, but anyhow, you've literally wrote the book on Venus a few years back, the book Venus Revealed. So Venus is one of your planetary objects of affection as a working scientist at the Planetary Science Institute based in Arizona, but you're in a satellite location there in Washington, D.C. So just welcome back to Star Talk.
Thanks. Yeah, Venus has been an obsession of mine, since graduate school, and so it's always fun when you see it. When I see it get a little extra attention.
Well, what we did was we solicited, as we always do for Cosmic Queries, questions from our fan base on all the various social media platforms about Venus, about the possibility of life on Venus. But Paul, you have all those questions, right? So I haven't seen them. I don't know, David, you haven't seen them either, have you?
I have not.
Yeah. So he's gonna pull out the hard ones.
Oh yeah. Okay, this is for a new car.
Wait, before you begin, I just want to establish this. So, David, you've been a planetary guy your whole life?
Yeah, I've been doing research projects with Paul McCartney and Kevin Costner. I have. I mean, literally my whole life, in the sense that even as a kid, like a lot of scientists of my generation, after the moon landing, that was it. I was going to be a space person in some way. And then I was pretty much obsessed with planetary exploration as a teenager. All the first missions were going out to, Venus and Mars and stuff. And then undergraduate, grad school, planetary science researcher. It's that's been my thing. Literally pretty much my whole life.
Paul might be your age, and so he had the same moon landing experience, but he didn't become a scientist. So, Paul, what happened to you?
Wow, I gotta go. I can't. If I want to be heckled, I'll do the 2:30 spot at the Comedy Cellar. I don't need this.
Right. The back room.
Exactly. Well, in 5th grade, I made a solar system out of styrofoam balls. So okay, beat that.
Oh, there you go. Okay.
No, it's just never been. I like science. I didn't feel like that was sort of my.
We have good
path.
science literacy. Otherwise, we wouldn't keep inviting you back. Just so you know.
I do. Thank you. Yeah, I do enjoy it. I do read up on it, and and when I leave these shows, I always feel both dumber and smarter at the same time. So it's
that's
good.
a good thing, actually.
Yeah,
that's a good thing.
Yeah.
So you know that you don't know everything, and you're proud of what you do know.
Yeah, exactly.
That's a good place to be.
Yeah.
So, Paul, what do you have for us?
Okay, here we go. First one is from Patreon. Izzy Roar. So much about Venus is still a mystery to us, and since our early reference point for life is Earth-based, isn't it hard to say that the phosphine found on Venus is a sign of life? Could it just as easily be caused by something that we never encountered before, and so wouldn't even know to think of? What do you make of it?
Whoa! And just start off by giving a 2-minute overview of that press conference and what news we're all reacting to here.
Yeah, so the big news this week is that it was announced that a discovery was made about Venus, which is that a gas called phosphine was detected in the atmosphere of Venus using 2 different radio telescopes on Earth, a spectroscopic signal, an absorption line that shouldn't be in the atmosphere of Venus, and they couldn't find any other gas that would explain it except for this gas called phosphine, which is just a phosphorus atom with 3 hydrogen atoms hanging off it, a simple molecule, which on Earth is only produced in our atmosphere basically by life or by industrial processes, including meth labs, but nobody's saying, hey, there's meth labs on Venus. But
Paul is pretty sure.
Yeah, probably. We'll go there for sure.
By the way, I hope this leads to an outer space reboot of Breaking Bad. That's all I want to see happen.
I think it needs to happen. So this is a surprising result because phosphine is a chemical that should not be in the atmosphere of Venus, meaning that if you just put some in the atmosphere of Venus, you would expect it to go away very quickly because the other chemicals there, you would expect them to eat it. It's not stable there. And so this is a known way of searching for life on exoplanets, especially planets around other stars where you can only look at the atmospheres, because the idea is that if something is producing an unexpected gas in an atmosphere, it could be a sign of life. And so there's this unexpected gas in the atmosphere of Venus, which on Earth is only made by life. And so the scientists have said, well, could it be volcanoes? And they did calculations and they said, no, there's no way it could be volcanoes. Could it be caused by lightning?
Venus has volcanoes.
Venus does have volcanoes, so that's an obvious thought. But if they've done their calculations right, and you can be sure all of this is going to be scrutinized, it ought to be scrutinized. Is there a problem with the observation? Maybe. Did they do their calculations wrong? Maybe there's some obvious way to make the phosphine they're not thinking of. But at this point, it seems like a big mystery why this biogenic gas is in the atmosphere of Venus. So, but the question is well taken because, yes, absolutely, it could be a sign of something else that we haven't figured out yet. It's just that nobody has yet figured out a good way to make it that's not life. So that doesn't mean, we found life on Venus. It means we found this mysterious indicator that has been, before this discovery, it was already published, the idea that if you found phosphine in an atmosphere, it could be a sign of life. So there it is.
Isn't one theory that this life, it's 800 degrees on Venus, but somehow some of it got into the atmosphere of Venus, which is more life-friendly? It'd be like 85 degrees Fahrenheit, I was reading, in that atmosphere, and that's where it sort of has maybe taken hold?
Yeah, Paul, that's a very important point because, anybody listening to this who knows, basic facts about the solar system knows that Venus is not a place you would expect life because the surface is 900 degrees Fahrenheit and it's hell there. So why are we even talking about this? But there's a layer up in the atmosphere about 35 miles up where there are permanent global cloud decks, and it's rather comfortable, at least in terms of temperature and pressure. It's like Earth's surface conditions, and there are potential flows of nutrients and energy and all the stuff you might need for life up there. And that's part of this idea that I've been pushing for a while. It's like, hey, there could be a habitable zone up in the Venus atmosphere.
And could you just go up with a mirror and see if there's any fog on the mirror, and then that's life form, like a dead body kind of a thing?
Well, that's the old days, yeah. Paul, how old are you? That was a 19th century way to know if someone was dead. You put up, see if they...
I'm 106 years old.
There it is, because if you fogged the mirror, that was evidence you're still alive.
Exactly.
Well, we're looking hard for techniques to go there and test this. So all suggestions are, we'll put that one in the in the hopper.
Bring a mirror just in case.
You never know.
Wait. So David, I don't know if you're a betting man, but let me just ask you: what are the chances it's actually life versus a completely yet to be discovered way to make phosphine that no one has dreamt of yet?
Yeah, man.
How do you balance this? Because both are extraordinary.
Yeah.
Right. Because we think we got a good chemistry. We've been doing chemistry forever, right? We think we got that. So if you're a betting man, where would you put it?
Yeah, boy, it's hard to put a number on it. That there's a third likely possibility, which is that maybe the observation is wrong, and it's very difficult inference. And to me, it seems as though it's very solid work the way they've described it. But people are going to be looking really hard and trying to repeat the observation, and maybe the phosphine will go away because it'll say, oh, well, actually, it's something else, or it was a mistake. But let's assume that there really is phosphine there. What are the chances it's life? So people keep asking me that. It's so hard to put a number on it. So yesterday on Facebook, I said, I'm going to say 5%, but I'll probably change my mind tomorrow. And, I reserve the right to have a very fluid opinion of this because we just don't know. And of course you have to, our friend Carl Sagan, extraordinary claims require extraordinary evidence. And if there was ever a place where this applied, we need better evidence, much more evidence before we say, oh, life. But this is a legitimate mystery that has a legitimate, logical path to infer that it could be life. And, whether that's 1% or 10%, I don't know. But it's less than 50%. It's more likely that it's something else. But it's not zero that it's life. And that in itself is a pretty exciting thing to realize.
And just for people to recognize, when you have results that are interesting and unexpected, they naturally attract more scientific scrutiny to see if it's correct. So that's a very natural urge that we all have. In fact, Paul, it's a problem if you get a result that's not particularly interesting and wrong very few people will find out that it's wrong because they don't care. So the verification process is not a level playing field, unfortunately.
Right. If you make a really interesting mistake, then everybody's going to know about it.
All right, so what else you got, Paul?
Move on? Okay. Philip Lyons, Patreon. My question is simple. When can we get a sample and bring it back to Earth to be studied? I think you can get it on Amazon, but you got to be a Prime member, and
they deliver tomorrow. You'll get it.
Exactly. No, it's actually August.
I'm sure
August 2032.
somebody's selling them on eBay right now, but I wouldn't, give it a lot of credence.
But that does leave the question, like, which I was thinking is sort of is this a parallel track issue of you make this discovery, but then you also have to create or invent a way to kind of confirm this or sort of get to the next level with this. So do you have to develop processes and techniques at the same time?
No, very much. We need follow-up experiments. I mean, first of all, just on Earth, in labs, people are going to be going crazy saying, well, let's mix phosphine in a Venus-like environment and put this and that. And can we do it? Well, how else can we make it? Just here on Earth, trying to simulate it. But you can be sure that we are going to be sending, some of us have been trying to send new missions to Venus anyways, and there's momentum. And I think this is going to be happening. Even I would have said that even before this discovery, but now there's that much more incentive. We've got to go there and understand what's going on there. Now, bringing back a sample would not be the next step. That's a hard thing to do. It's hard enough to bring back a rock from Mars, which, we've been trying for a long time and we're still trying, and there's something in the works, but it's not very easy. But an atmospheric sample from think about it. You're going to enter into the atmosphere, you're going to scoop something up, and then you're going to launch not from a surface, but from an aerial platform. And it's inherently harder to get something off Venus than Mars because it's a bigger planet with more escape gravity, or, with more gravity, higher escape velocity. So that, I think, probably will be done eventually. But the next step is actually to just go there and do experiments in place, bring the right scientific instruments into the atmosphere and the clouds to investigate and send the data back rather than trying to bring a sample back. And that,
David, you're not talking about rovers because this is 35 miles up in the atmosphere, so you need some kind of floater.
Yeah. Even, the easiest thing to do is just drop an entry probe and you're briefly traveling through that environment and you take measurements on the way down. That's been done, but not in the 21st century with modern instrumentation. And that you can still learn a lot, even with a quick trip through with the right instruments sending back data. But then, as you say, Neil, it would be even better to bring a platform where you could reside in the clouds for a while, either a balloon or some kind of a solar-powered glider. There are plans and ideas to do this. And I think, a balloon would be great because then you could actually spend some time and sample more than one location and, really look around and get to know the environment a little bit rather than just flying through it.
Mm-hmm. I have a quick question related to this. So if the heat weren't the issue, is pressure on the surface also an issue here? Because it's 90 times that of Earth. So you have to grapple with that at the same time as the heat issue in terms of trying to find the sample, right?
Yeah, Paul's showing off that he did his homework before.
No, I did not.
Yeah.
I have my 6th grade science teacher sitting off to the side right here, and he's
because he said that all casual.
Me.
Well, it's got 90 times their pressure.
That's pretty good. Yeah,
that's pretty good.
Yeah, no, that's yet another reason why the surface environment is a very challenging environment, both for life to survive and for our machines to survive if we want to go investigate it, which we should. The mystery of Venus, even if we're talking about a mystery up in the clouds, it's related to surface processes because, one of the things that makes Venus such an interesting planet is that it seems to have an active surface, and that's connected to the chemistry of the clouds. There are
active. You mean geologically active?
Yeah, geologically active, and that seems to include active volcanoes, which is really important for this story. Although, I say seems to include, we've got a lot of circumstantial evidence. We don't have what they call the smoking gun, where we've seen a volcano going off, but there are clues in the atmosphere and on the surface.
Smoking volcano.
Yes, exactly. The smoking caldera. We don't have that. But we see things in the atmosphere and patterns on the surface that make the most sense if there is active volcanism. So we think there probably is on Venus, but we want to confirm that. But it's important to this story because it's probable that the chemistry, whatever's going on in the clouds, has to do with gases that are coming out of the circle and cycling through the atmosphere and then reacting with surface rocks. So just as on Earth, we talk about the carbon cycle and these different chemical cycles, on Venus, there's a sulfur cycle and probably other sulfur cycles involving the clouds in the atmosphere and the surface. So if we want to understand what's going on in the atmosphere, ultimately, we do have to investigate the surface. But you wouldn't need a rover or something like that to do a dedicated mission just to look at what's going on up in the clouds.
So if there's a sulfur cycle, that's where you get, I've always read that Venus has sulfuric acid droplets in the upper atmosphere. And I always wondered, how'd they get there? Why don't we have some of that? And so it's got a sulfur cycle, huh?
Yeah, I mean, interestingly, we do have some of that. And when there's a big volcanic eruption on Earth and you get those colorful sunsets and sometimes there's even a temporary cooling because that stuff spreads through the stratosphere, that's actually mostly sulfuric acid droplets that you get a little bit of temporarily on Earth. But on Venus, of course, the clouds are almost all sulfuric acid, and we believe that is related to volcanic flow from the surface. Again, this is something we want to verify with more investigations and missions, but calculations that actually, which I did with my research team several years ago, where we tried to look at the lifetime of the cloud particles, we actually believe that the clouds would go away in about 10 million years or maybe 30 million years if they weren't continually fueled by a flow of sulfuric gases from the surface, which, if that's true, it's pretty cool because it means that when you go out at night and you observe Venus with your naked eyes and you see how beautiful and bright it is, you're actually observing the effect of volcanoes on the surface, because the reason why Venus is so cloudy and so bright, and you can see that on any given evening or morning when Venus is in the right place, that is connected, we believe, to an ongoing existence of volcanoes. So you can verify that with your senses.
Is there anything here on Earth like sulfur springs that we can use or can use to advance our knowledge to work in this capacity in the context of Venus and phosphine and all of that?
We got to get to that answer after this break. Okay, so Paul Mecurio wants to know if there are sulfur creatures in hot springs on Earth when Star Trek returns, Cosmic Queries, the Venus edition.
Exploring the secrets of the cosmos is a fascinating pursuit, but have you discovered the vast and incredible potential of your own mind? Introducing Advanced Nootropic Formula from V-Thrive, the Vitamin Shop brand. Available at vitaminshop.com or your local Vitamin Shop store. This stimulant-free formula supports cognitive function, neuron development and repair, and brain-derived nootropic factor to promote the survival of existing neurons and encourage growth of new synapses. Non-GMO Advanced Nootropic Formula features clinically studied ingredients like Synapsa for peak cognitive performance, Cognizant for mental energy, focus, and attention, and clinically proven in extras so you can stay extra sharp. In fact, you may experience an improvement in alertness for up to 5 hours. As always, all V-Thrive, the Vitamin Shop brand products, are simply clean with no magnesium, stearate, stearic acid, or titanium dioxide. Advanced Nootropic Formula comes with a quality promise you can trust with ingredient purity and potency verified by independent third-party labs. The best part? It's on sale. Save 15% on purchases of $40 or more when you use code STARTALK at vitaminshop.com today. Again, that's 15% off purchases of $40 or more with code STARTALK on vitaminshop, SHOPPE.com to expand your mental universe today. Are you always taking care of your family? Do you often take care of others and not yourself? Well, now's the time to take care of yourself because you deserve it. Teladoc gives you access to licensed therapists to help you get back to feeling your best, to feeling like yourself again. Sometimes we don't know how much we need to talk to somebody. Take it from me personally. During the entire pandemic, I have had virtual sessions, and it has been such an incredible help. Now, with Teladoc, you can speak to a licensed therapist by phone or video. Therapy appointments are available 7 days a week from 7 a.m. to 9 p.m. local time. Hey, maybe you're feeling overwhelmed. Maybe you feel stressed or anxious or depressed or lonely, or you might be struggling with a family issue. Teladoc can help. No need to wait months to get a therapist. Teladoc is committed to facilitating great therapeutic matches, so they make it easy to change counselors if needed for free. Teladoc therapy is available through most insurance or employers, and individual plans are also available. Download the app or visit teladoc.com/StarTalk today to get started. TELADOC.com/StarTalk.
We're back. Cosmic Queries, the Venus edition, Life on Venus edition. Paul Mecurio, my co-host. Paul.
Hey, how are you?
All right, dude. We had David.
This is
Grinspoon.
awesome. This is like I feel like this should be like a master class, that series, and I should be paying money or something. This is amazing.
Yeah, you'll get our bill. That's fine. But right when we left, you had a question. This wasn't from our list, right? You posed the question.
Yeah.
Whether our sulfur springs can help us understand sulfur conditions on Venus.
Yeah.
Inform
us in any way.
It's very, very relevant to this whole story because, one of the ways we try to understand where in the universe there may be potential for life is by looking at the range of conditions that life can inhabit on Earth. And as we've learned more and more about what we call these extremophile organisms, the lovers of extremes, we realize that it's a much wider range of conditions than we once thought. And there's a whole category of extremophiles that are acidophiles that we've discovered, organisms that love to live in strong acid, including acid hot springs of the kind you mentioned. And that's one of the reasons why some of us think that, we shouldn't fully count out the clouds of Venus as a habitat. Now, it's true the clouds of Venus are more acidic than the places on Earth so far that we've found acid-loving organisms. But we do not know really what the extreme limit of how acidic an environment can be and support life. And so people that are interested in these questions, they study that environment you mentioned, the acid hot springs. They go on field trips to places like Yellowstone, and they look for life that lives in these extreme environments that are at least more Venus-like than other places on Earth.
So David, when tourists go take hot baths in these sulfur springs, would you consider those humans extremophiles? I'm just wondering.
Yeah, absolutely. I mean, I guess I love hot springs, and so I guess next time I'm in one, I should contemplate the fact that I am an extremophile. Yes.
I think it depends if they're wearing a bathing suit or not. If they're not wearing a bathing suit,
there you go.
They are very bold people. Yeah. Should we move on to the next one?
Yeah, Paul. Keep going.
All right,
Paul's got the questions. This is Cosmic Queries.
This is Vincent Zimmerman on Twitter. Is there life in the clouds of Venus? What liquid is that life using? On Earth, we use water as solvent. I think it's Ciroc vodka, isn't it?
That's right.
No, it's sort of related to what we were talking about, but an extension of that.
Yeah, no, I mean, absolutely. I mean, one of the challenges is, as far as we know, life needs water. And that, as far as we know, has to be emphasized because maybe we're just not being imaginative enough. And so much about the universe we learn through exploration, not through modeling and expecting what we're going to find. And,
Wait, so is it that life needs water or that life needs liquid?
Yeah, well, that's a great question. So you could look at it both ways. The chemistry of life, you could think of life, on Earth as this dance of organic molecules, which take advantage of the fact they're in liquid, so they can do this, 3D coming together and doing all the complex interactions that molecules do. It's hard to imagine that happening not in a liquid medium, and people have said, well, what about ammonia or this or that? Or, it's an interesting question, although nobody's come up with a full theory of how that would work. Maybe that's just because
I saw a comic, it might have been the New Yorker, where there's the alien crash lands in the desert, and it's crawling along the dunes, and it says, ammonia.
Yeah, exactly. Yeah, so are we just being geocentric when we say life needs water?
Yeah,
this is
hydrocentric,
This is one of the hydrocentric. This is one of the great questions.
Earth with all of your fancy water. Ooh.
and this is one of the big motivations for finding alien life. I mean, of course, the biggest motivation is just we want to know, are we alone? But in terms of the science, once we have multiple samples, molecules, then we could start to really address this question. Is it all basically the same chemically, or are there completely other bases? So most of what we do is search for water-based life when we think about astrobiology and other environments. Maybe that's just our narrow-mindedness, but you got to start somewhere, and we at least know how life in water would work. Now, sulfuric acid is kind of a borderline case because in a certain sense, it is water with just a lot of acid mixed in. It's a concentrated mix of, it's water with the sulfuric acid molecules. And so in a certain sense, the clouds of Venus are strictly speaking a water environment. It's just that we don't know of life that can live in water that's that polluted with a strong acid. So would it be life as we know it? It's borderline. It would have to be life that had evolved these sort of mechanisms to maybe pump its interior free of acid, or a different kind of chemistry that can work with those acid molecules. So it's.
But in response to the question, there is plenty of liquid.
There's plenty of liquid there, and that's one of the things that makes some of us, not want to rule out that environment.
All right. So what else you got, Paul?
Twitter at Doodle Whoopsie.
Doodle Whoopsie.
Doodle Whoopsie, yeah.
Whoopsie.
Or,
a big fan of the show.
Yes, exactly. It's Whoopsie Doodle at Doodle Whoopsie. Apparently, I guess at Whoopsie Doodle was taken already, so they had to flip it. Anyway, hi, Dr. Tyson.
Or they're living backwards in time, and it reads forward to them.
Exactly.
Yeah.
What is the most basic and trusted way to search life in the universe?
Oh, that's a great question. Of course, there's a lot of effort going into answering that. But interestingly, the most common answer you would probably get now, especially because we have discovered exoplanets and we want to know what they're like and if they might have life, all the planets around other stars that we can't just send a spacecraft to, in a few months. It would take a few centuries. So we have to rely on remote observations. And the best way is to search for weird gases, anomalous gases in the atmosphere, like phosphine, for instance. So, wait, just to be clear, it's not just that they're weird gases, they're gases associated with the existence of life. Yeah, weird in a particular way, that's right. Out of equilibrium, things that shouldn't be in the atmosphere and are plausibly associated with some kind of biological metabolism.
Paul, did you know that humans and life in general is hugely out of equilibrium with its environment? Did anybody ever tell you that?
No, what does that mean?
It means.
And are you really just talking about me, that I'm out of equilibrium with the rest of the world?
It's not just you, if you've been wondering. We're all out of equilibrium.
No, just think about it. I mean, the air around you, let's say, is 72 degrees, and your body temperature is 27 degrees warmer than that. And it stays that way. That's not in equilibrium with your environment.
What accounts for us being able to exist in that way if we're out of equilibrium?
You keep eating.
Yeah, you regulate your internal environment and you put energy into that. But also Earth...
Yeah, by the way, if I stop giving you food, you will eventually be... you will die, and you'll reach the temperature of the air, and then you'll be in equilibrium. Is that what you want, Paul?
Yeah, I think I do. No.
And all your molecules will oxidize. I mean, the thing is, Earth itself is not in an equilibrium state. If you were an alien looking at our atmosphere, you'd say, what's all that oxygen doing there? And what are these traces of methane doing there? And, there are things in our atmosphere that would not be there on a lifeless Earth. And that's the idea, that we learn to understand what life does to its atmosphere, and then we search for those signs elsewhere.
So those greenhouse gases are knocking our environment and the people that live in it more out of equilibrium, then, right? Because we're not in a natural state of...
Yeah, not just greenhouse gases, but some of them are greenhouse gases, which is very interesting because then life starts to interact with the climate of a planet. Methane, I mentioned, is a greenhouse gas, and it is, at least partly on Earth, a product of life. And then you get to these weird potential mechanisms where life can feed back on the planet and do things like change its own climate.
Oh, interesting. Yeah, it's amazing. So, I mean, what is there a basic or trusted way? Not necessarily. There are a lot. Do you find life? Do you leave food out overnight, like treats, and if someone comes and get it, then there's life? Like what? No, what is there to address Whoopsie Doodle's question? Is there something?
How about this, David? If you just rank the gases top three, that would be the most tantalizing suggestion that there was life, what would it be?
Oxygen, which is not 100% because there are non-biological ways to make oxygen. But if we saw a planet with as much oxygen as Earth, we'd go, wait a minute, what's going on there? And at least you consider life. Methane is a good one. Again, there are other ways to make it, but we find little wisps of methane on Mars and we go, what is that? And life is at least one possibility, but there are others. And I would actually...
farm animals on
that's right.
Mars.
Yeah. Cow farts. Yeah.
They're cows on Mars,
Yeah.
Mars cows.
But interestingly, phosphine is potentially...
Wait, just to be clear, David,
Yeah.
just to be clear. Paul, I don't know if you knew this, right? So methane is the byproduct of anaerobic metabolism, which goes on in the guts of animals,
Right.
especially in ruminants, right, like cows. And methane is the gas that's the gas of choice in cities for gas stoves. So that old camp thing that you always wanted to do, to see with a lighter if it's flammable,
Yeah.
it's really true. I just wanted to establish this.
I tried that on the subway and got arrested for it. So apparently you're not supposed to do that on the subway.
No, you're not.
You were doing atmospheric disequilibrium experiments on the subway.
Officer, I'm a scientist. I'm just trying to explore the universe more.
I'm sure that was very effective. Yeah. But so top three, oxygen, methane, and then, quite possibly phosphine is in that top three. It's been, there have been, before this discovery on Venus, there were papers that were published saying that phosphine is an ideal biosignature gas, an ideal sign of life, because it's hard to come up with mechanisms to make it on a rocky planet that are not biological. Now, you can be sure, every chemist on Earth since Monday is now trying to come up with new ways to make phosphine. And, if we don't learn about life on Venus from this, we will learn new things about chemistry on Venus because somebody's going to figure out some other way to make phosphine that we didn't know. But right now, it's in the literature as a very promising biosignature gas that if you found it on an exoplanet, you'd say, hey, wait a minute, this could be a sign of life. So it's pretty wild to find that gas right here on the planet next door.
And just to be clear, the rover that is en route to Mars right now, Perseverance.
We'll just call it Percy.
Percy, I like that. So just to be clear, Paul, we can look at the chemistry of the atmosphere of these exoplanets. Or, if an alien comes out from under a rock and rides the rover, that would count as evidence too. Like, wouldn't it, David?
Yeah. No, I mean, it's true. I mean, the question is, it's a really good
if they
question.
start taking selfies with the
exactly.
rover camera.
No, I mean,
it's life.
It's a really good question. What's the best way to find life? And, we focus a lot on these gases that we could find on exoplanets because that's all you can do on exoplanets right now. But absolutely, when we send instruments with cameras, it's worth looking on a place like Mars. Especially the first ever landers on Mars. Carl Sagan used to talk about, well, we should at least take pictures and see if there's a turtle walking by. Because who knows? Or even look for turtle tracks in the sand.
Or maybe there's like a probe from another planet or Venus, and in it is their version of a Chuck Berry song. So then we know.
Oh, yeah, exactly.
We know that there's life there.
Yeah. Actually, we got to take a quick break, and we'll be back with our third and final segment of Star Talk Cosmic Queries, the Venus edition.
So you're ready to earn your degree, but you need a university that works with your schedule. Well, WGU and their programs are built to be flexible. WGU offers a quality degree program that's affordable and even makes it possible to graduate faster. Plus, you can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. That's right, you heard me. That is the correct, $8,700 per year. Let your experience and dedication help you earn your degree faster. See what WGU's competency-based programs can offer you. With no set login times and 24/7 access to most coursework, you can really earn a respected bachelor's or master's degree on your own schedule. The low tuition rate covers as many courses as you can complete each term. That means the faster you learn, the more you'll save. Get your $65 application fee WAVED at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee. Poof, gone, waived. Time for a Patreon shout out to the following Patreon patrons: Patrick Gibbs and Jonathan O'Rear. Guys, thank you for the gravity assist as you help us make our way across the cosmos. We couldn't do it without you. And for those of you listening who would like your very own Patreon shout out, go to patreon.com/StarTalkRadio and support us.
We're back. Star Talk Cosmic Queries, the Venus edition. Paul Mecurio, my co-host. Paul, what's your Twitter handle?
At Paul Mecurio, Mecurio, one R, my last
Very
name.
creative.
Yeah, I tried.
Just the guy.
I'm sorry I can't be whoopsie doodle doodle doodle, you know?
All right.
Yeah.
So Paul, give me some more.
Matt Harefield, Patreon. How do you think life would have evolved under the conditions on Venus? Does Venus have liquid water at some point? Did Venus have liquid water at some point?
Quick answer.
Go back in time, David.
Yeah.
Go back in time.
Yeah.
What are we talking about?
Quick answer, we think Venus had oceans when it was younger. We're not exactly sure how long they lasted, but they might have lasted for billions of years. And then the idea is probably if there was an evolution of life, it started and advanced on the surface, and then when that surface broke bad, then maybe it ended up in the atmosphere.
I mean, if there was life and it did evolve, it had, with the harsh conditions, it had to be complaining like the whole time, like, it's so hot, I can't go out. Oh, where's my hat?
And with their runaway greenhouse effect, they just burned too many fossil fuels. That was their problem.
Well, actually, that's
those irresponsible Venusians, man.
Well, Jake,
No, but interesting, David. I didn't thought of that. If there was life on the surface and that became inhospitable, and they had some way to fly, then they could just continue to ascend away from the heat. And so for all we know, there's whole floating cities in this layer of the atmosphere where they found the phosphine.
Yeah, I mean, we're starting with the hypothesis of microbes, but we don't actually have observations that would rule out something much more complex. And so,
in the movie Avatar, they had floating islands because of unobtainium.
The Jetsons? What about the Jetsons?
I forgot the Jetsons.
All right, so...
I was just thinking about the Jetsons recently. This is a stupid, completely irrelevant comment, but, the Flintstones pioneered chewable vitamins, right, for kids, and that they still sold for sale. And I thought to myself, they're the Stone Age. They wouldn't have known anything about vitamins, but the Jetsons would have. So there really should have been Jetsons chewable vitamins. That's what I'm thinking.
That's very profound, Neil.
That felt a little passive-aggressive. I got to be...
All right, Paul, give me some more. What do you got?
We will go to Ashley Steadley on Facebook. Could these be the same extremophiles that were on early Earth? If these are microbes or bacteria, what might happen if we brought some to Earth?
Two good questions.
Yeah, Dave, if we go to Venus with a sample return, and oh my gosh, there are bugs and there are microbes, that doesn't sound very, very wise.
Yeah, I mean, we always consider what we call planetary protection when we talk about sample returns, especially from a possibly inhabited environment. How do you be really sure you're not bringing something back that could be dangerous? And so, there are protocols where you keep it in a contained environment at first. If you're talking about life in the clouds of Venus, I think, of course you always want to be cautious, but that seems like less of a consideration because it's such an extreme environment. It doesn't seem like it would very easily overlap environments on Earth that are inhabited. So it's probably the case that if there were Venusian bugs in an extreme acid environment and they sort of got out of your laboratory, that they would not do well and not be able to multiply and hurt anything on Earth. That's my first reaction, but I also think we're inherently cautious about these things. As far as the first part of the question, could these be similar to life on early Earth? It's possible, but we don't know that much about the environment of early Earth, and it's true that some of the theories of origin of life involve hot springs on early Earth, but probably not as extremely acidic. So I want to say they're not it's not my picture of the first life on Earth, but on the other hand, we're still very ignorant about what that early life was like, and so it's not impossible.
Is it fair to say that if you brought a Venus bug here, it would say, "Oh, it's not acid enough. I'm dying. I'm melting. I need more acid"? Is that would it pull a Wicked Witch of the West on us? But
it would, but it would say it in Venusian. So,
well, I don't know about if it's anything, I lived in D.C. and when I moved back home, I brought cockroaches with me, and man, all hell broke loose. So, maybe they have cockroaches. They seem to live everywhere.
That's a good example of why we do planetary protection.
Yeah, and well, this also, by the way, could be a movie. The three of us should pitch Venus. Microbes come to Earth, and it's a movie. And Paul Giamatti is the misunderstood, clever, brilliant scientist who's the only one that sees the problem. I think that's a movie we should pitch. But
Paul Giamatti is playing me.
Sorry about that.
I just want to pursue the Wicked Witch of the West scenario again. I mean, think about it. Presumably, they only poured a bucket of water on her, and water is acidically neutral, correct? So if she
that's a good point. Why did water make her melt?
Right, and I'm saying because she must not be acidically neutral. She's either very acidic or very basic. In either direction, she's far away from what water would do.
She was from Venus.
She was from Venus.
She was actually the Wicked Witch of Venus.
I thought there was something extremophile about her. I really did.
And it's evidence that aliens are green. Just to put that one to
so maybe there's flying monkeys there too.
Right. Boy, those scared the heck out of me when I was a kid.
Everybody.
Didn't they? Everybody. I mean, the guy, why? This isn't fun. You can't list this as a comedy. What is this? This is it was the worst. It's you got a green woman, no fashion sense. The witch had no fashion sense. It was either all black or way over the top with jewels, slippers. Don't get me started. All right. We'll go to another one.
Paul, I didn't know you still had issues.
I do. I need a hug. I need a Venusian hug. All right, we're going to go to another one?
All right.
All right, here we go.
Yeah, let's get through them quick so
here we go.
See as many as we can do.
All
Go.
right. This is Instagram, Sam Z. Hi, Dr. Tyson and Dr. David. So if Venus is a terrestrial planet, then why is the atmosphere's pressure so high? Also, you mentioned in a previous video that Saturn protects us from asteroids and stuff. What, if anything, does Venus do for us?
Okay, personally, I wouldn't have said Saturn. I would have said Jupiter, because Jupiter has all the good gravity out there to bat wayward comets and asteroids out of harm's way. But David, why is our twin sister planet so different from us?
Yeah, so I mean, you said if Venus is a terrestrial planet. Well, terrestrial planet really just means rocky planet. Like Venus, Earth, Mars, Mercury, and they can have all different kinds of atmospheres. We've learned that just in our solar system, and we imagine if you included the terrestrial planets out there in the galaxy to be even more diverse. But the reason why Venus's atmosphere is so thick, we think has to do actually with the very high temperature in a kind of feedback where once it gets that hot, it's hard to remove gases. The reason why Earth doesn't have that much carbon dioxide in its atmosphere is because there's a carbon cycle, where carbon dioxide over time gets removed from the atmosphere and turned into carbonate rocks. That cycle depends on water and rainfall, where the water gets dissolved in rainfall and runs over the rocks and reacts and ends up, some of that carbon ends up as ions in the ocean and then gets precipitated on the surface and then ends up in the interior. There's this whole complex cycle on Earth where carbon is removed from the atmosphere. But if you take an Earth and you dry it out so there's no surface water and no rainfall, then the carbon dioxide's still coming out of the volcanoes over millions of years. It's going to build up, but you've sort of broken the part of the cycle where the water helps you remove the carbon from the atmosphere. So we think that's what's happened on Venus, is that once it lost its surface water, it still kept accumulating carbon dioxide in the atmosphere, but now there's sort of no way to pull it out, because you don't have those chemical reactions mediated by water. So it's sort of stuck with all this atmosphere and no place to put it.
Is there any understanding why the water on Venus disappeared? Have we been able to figure that out at all?
Well, so there's this idea of the runaway greenhouse, because water itself is a greenhouse gas. It absorbs infrared radiation. So you add water vapor to a planet and it's going to heat up. So then you can have this feedback where if there's a certain amount of sunlight hitting a planet like Venus that used to have oceans, presumably, then that evaporates some of the ocean, which increases the amount of water vapor in the atmosphere, which heats up the planet more, which then evaporates more of the ocean. So it can kind of run away. So that may be why Venus lost its oceans, although we're still sort of really trying to figure out that history. And of course, the details get complicated and are debated.
Well, basically, you're saying the aliens on Venus had a terrible energy policy, and when it hit 500 degrees, they should have done something about it, but they totally ignored it. That's what you're saying.
They totally, yeah.
Do not let this happen to your planet.
Okay. Have astrobiologists, this is David Hemsath at Patreon, have astrobiologists previously tried mapping Earth's extremophiles to Venus's environments?
Ooh. Let's make that a bigger question. David, all the Earth's extremophiles, can we find a place for every one of them in the local solar system or even across the galaxy?
Wow, that is a much bigger question. That would be a fun exercise, actually, to
I think so.
take the whole map of all the extremophiles and then take either real or imagined planets and say, this is the planet where these guys would be at home, and here's what its qualities are. I don't know of anybody that's done that, Neil, so we should talk. That'd be a fun thing to do. As far as mapping specific extremophiles to Venus, people have tried, and there are organisms that sort of get us closer there. I mentioned acidophile, acid-loving organisms. As far as we understand the clouds of Venus and their conditions, and again, this is a region that we need to explore more carefully, there's no known Earth organism that you could just plunk there and it would be happy and say, I love it here, and just multiply and keep living. But there are organisms that sort of get us partway there, that are resistant to ultraviolet light and that are that can exist in strong acid. And there's a big effort now also to figure out what's living in Earth's clouds, because there are organisms in Earth clouds, but we still don't understand their sort of entire life cycles. So there's an area of investigation where we do look at extremophiles and try to map them into Venus's conditions, but nobody's sort of nailed it and said, here's this bug that would love it there.
I saw that episode of Watchmen where a squid comes from the sky. It rained squid in one of the episodes, just so you know.
Aren't there actual historical recountings of like frogs raining from the skies and weird episodes that are...
Maybe there's a whole biota in a layer of the atmosphere and we're discounting these legends and these mythological accounts, but in fact... it's another place. It's like Oz. It's beyond the reality of what we accept.
Next week on the History Channel.
Squid NATO. and you and Neil are fighting squids falling from the sky inexplicably, and you've got guns and lasers. We got two.
Yeah, there you go.
We got two movies we got to pitch now. There's a lot to do. Should we do one more?
Go.
Ishan Basi on Instagram. There have been a few Venus missions in the past, although none of them survived for very long. Is there a slight possibility that they might have introduced this life form into the atmosphere of Venus?
Ooh, love it.
Quick answer, I'm going to say no, because when something falls into the atmosphere of Venus, it's surrounded by a ball of fire before anything, and then there's this basic fact that the conditions are just so different that it's hard to imagine something leaping off a spacecraft and surviving.
Come on, not like a discarded Taco Bell cup, nothing? There's got to be something. Plastic supermarket shopping bags? Come on.
Wait, David, viruses get around, viruses invented people so that people would invent airplanes so that viruses can go transcontinental and infect more people.
That's true, but viruses... so we could have...
Darwinian evolution accounts for that.
So we could have dumped some viruses accidentally on Venus, but viruses don't live without other cells to invade. So I still don't think the viruses would be thriving there.
And doesn't your answer presuppose it's sort of the lack of knowledge we have, which is infinite, right? So in other words, we don't know if there is some form of life that could drop into that atmosphere and survive because we don't really understand it yet.
I mean, you asked for the short version of the answer. The longer version is like, well, caveat, caveat, caveat. Who knows? Maybe this, maybe that. But
Paul, stop leading him on.
All right, sorry. Okay, sorry.
Stop baiting him.
I'm trying to stretch this answer out. All right.
Let's go. One more? A quick one.
Okay,
Quick one.
all right,
quick,
here we go.
And
Chamorro,
David, I want a one-word answer to this one, whatever it is. I don't care. Okay.
Chamorro
Go,
Life
Paul.
Instagram. Can life in Venus exist in the animal ballpark or just as microbes/bacteria?
Ooh.
maybe.
Excellent. We got to stop it at the maybe. Paul, always good to have you on the show.
Always a lot of fun. Always learn something. Thank you for having me.
And David, don't be such a stranger, dude. It's been too long since we've had you on the show.
It's true, especially when this pandemic is over. We got to go out for a glass of wine.
Yeah, and we'll get you to play some more Alien Blues.
I'm ready
for us. Okay.
Acid-loving Venusian blues.
Acid-loving Venetian blues. This has been Star Talk Cosmic Queries, the Venus edition. I'm Neil deGrasse Tyson, your personal astrophysicist. Keep looking up.
So you're ready to earn your degree, but you need a university that works with your schedule. Well, WGU and their programs are built to be flexible. WGU offers a quality degree program that's affordable and even makes it possible to graduate faster. Plus, you can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. That's right, you heard me. That is the correct, $8,700 per year. Let your experience and dedication help you earn your degree faster. See what WGU's competency-based programs can offer you. With no set login times and 24/7 access to most coursework, you can really earn a respected bachelor's or master's degree on your own schedule. The low tuition rate covers as many courses as you can complete each term. That means the faster you learn, the more you'll save. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee. Poof, gone, waived. With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil deGrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay, to communicating with your boss, to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio. Radio.